Hi, we're going to take just a few minutes and talk about section 4.2, which is all about linear functions and equations of lines. This will likely be a review, but there may be some details that you've forgotten. So we'll get started in just a minute. But before we do that, I want to give you a quiz over the material in the previous video. So let me share my screen with you. Okay, let's have a quiz. I meant to include this at the end of the last video, but I forgot, so we'll do it now. And what I want you to do is for the function f of x equals x squared minus 3x plus 4. Find first the difference quotient f of x minus f of a all over x minus a. And second, the difference quotient f of x plus h minus f of x all over h. All right. If you need to pause this to write those down, go ahead, but this is your quiz for this lecture. Now let's go ahead and talk about section 4.2. And this is about linear functions and equations of lines. I'm going to focus primarily on equations of lines. And I'm actually going to not talk about the basic slope-intercept form because I think most of you know that y equals mx plus b. What I want to talk about again, or instead, is how to do a problem that looks like this. So suppose I'm asked to find the equation of the line with slope -2 that contains the point -4, 3. All right, there are two ways to do this, and I'm going to show you both of them. The first thing we need to remember is what we need in order to find the equation of a line. We need a slope, in this case, -2, and we need at least one point that is on the line, in this case, -4, 3. All right, the first way we can do this problem is just with our good old friend, the slope-intercept form of the equation. Now, the thing we have to be careful with is that we need to remember what b is. We know the slope. We know the slope is -2. That's easy. What we have to remember is that b is the y-intercept. And we have to remember that the y-intercept always has an x-coordinate of 0. So in order to find our y-intercept, we can't just pick up this y-coordinate. That's not going to work because the x isn't 0. But what we do know is we know an xy pair that lies on this line. So we can plug in 3 equals -2 times -4 plus b. What I've done is I've plugged in my xy pair that I know is on the line. And this now will allow me to find my y-intercept. So I've got 3 now equals 8 plus b. Subtract 8 from both sides of this equation, and we get -5 equals b. Now the answer to my question is actually the equation of the line. So my answer will be y equals -2x minus 5. Okay, that's one way of solving this. Now, you may have seen in a previous class what we call the point-slope form. Of the equation of the line. And what that says is that y minus y1 equals the slope times x minus x1. And x1, y1 is some point on the line. So what we're going to do if we use this form is y minus the y-coordinate of some point on the line, which in this case we have is 3, equals the slope, which is -2, times x minus the x-coordinate that goes with the y that we chose. So we chose y equals 3. That means we're going to use x equals -4. Do a little work, and we get y minus 3 equals -2x. Now be careful here. Minus -4 is plus 4. Multiply by -2, and we get -8. Add 3 to both sides, and y equals -2x minus 5, which is the same answer we got before. So you can use either form of the equation of a line to solve these types of problems. You can either use the slope-intercept, which is y equals mx plus b, or you can use the point-slope form, which is y minus y1 equals the slope times x minus x1. They are both different ways of writing the equation of a straight line. Okay. I'm checking through the textbook, and that is the basics of finding the equations of a line. There's a little bit more you might need in the text, and I'm going to show you one more thing here today. I think I still have time. And that is piecewise defined functions. Now, piecewise defined functions are a little different because they're not defined by a single equation. And probably the best example of a piecewise defined function is a shipping chart or the postage rates for the United States Postal Service. And if we think about that, and I'm sorry I don't have that downloaded, so we're just going to talk about a generic shipping rate. So in the old days, before everybody ordered everything from Amazon, me included, you had to fill out paper order forms, and you had to figure out what your shipping was going to be. And the shipping might have looked something like this. If your order total was less than $20, shipping would be $4. If your order total was between $20 and a penny to, we'll say, $30, shipping would be $5. I'm just making this easy. If your total was $30 and a penny to 45, shipping would be $6. And let's say if it was more than $45, shipping was $8. Okay, now if we look at how to graph this, because I don't have any negative x's or negative y's, I'm just going to worry about this first quadrant. What this column does, so this column is my x's. This column is my y's. $10, $20, $30, $40, $50, $2, $4, $6, $8. All right. So if my x values are less than 20, and the way I wrote that, that's going to be strictly less than. I'm going to go ahead and make that filled in though. Then my shipping is $4. Now, am I going to have to pay if I don't order anything? No, so we'll put an open circle on the 0. If my shipping is more than 20, but no more than $30, I'm going to pay $5. If my shipping is more than 30, but no more than 45, I'll pay $6. And more than 45, out to infinity, I pay $8. Okay, that's a practical example of a piecewise defined function. They're not always defined as tables. You can have a piecewise defined function that looks like this. F of x equals -2 if x is less than or equal to 1, and x minus 3 if x is greater than 1. So this is kind of the same thing, it's just sort of sideways, almost kind of backwards. These conditions over here on the right tell you which rule to apply. So for example, suppose I want to find f of 0. First thing we have to do is ask ourselves, which category are we looking at? Is 0 less than 1? The answer is yes. So we apply the first rule, -2. What is f of 2? Is 2 less than or equal to 1? No. So we go to the next category. Is 2 greater than 1? Yes. So we apply the second rule, which is going to be 2 minus 3 or 1. So if we want to graph this it looks like this. Everything happens at 1 in this particular function. So if x is less than or equal to 1, make this 1, -1, -2, -3. If x is less than or equal to -1, my function output is always going to be -2. Now let's make a table. Well, we can just plot some points. If x is exactly 1, we're here. But if x is 1, 1 minus 2 is -2, so we're going to start right here. So I'm checking to see where my starting point is for the second function, the second category. May or may not be the same place. Remember that shipping total we did just a minute ago. All right, if x is 2, y will be 2 minus 3 is 1. And now this is a straight line. Okay. Don't overthink piecewise defined functions. Don't make them any harder than they are. They really aren't that bad. If you have any questions or troubles, please reach out to me in email or post on the forums. I'll talk to you all again soon. Sorry, wrong button. Here we go.